Welcome to our research presentation. Again, my name is Bryce Hooley, and the title of our presentation is Voices in the Wetlands, Amphibian Detection and Distribution in the Ephemeral Wetlands of the Alapaha River, WMA. So a little background into what our research is about. So about 5 to 10% of the world's land surface is currently wetlands. Of that 5 to 10%, over 70% is either currently destroyed or is being in the process of being destroyed. A lot of the threats from this come from habitat degradation, which habitat degradation is when the habitat is declining in health due to human-caused factors such as pollution. Without constant monitoring and assessing of this health, we could lose these habitats for the futures to come. A common way of assessing the health of these wetlands is through the use of bioindicators. A bioindicator is a species that lives in the habitat and is sensitive to any changes in that ecosystem. Amphibians are a common group used for this due to how prolific they are throughout the world. They are found in terrestrial and aquatic habitats. A common variety is frogs. Frogs have been used, again, mostly because of their low movements and their water-permeable skin. There was one research done in India where they used frogs to assess the effects of pollution on agricultural runoff.
Our goal for our project was to identify which wetlands are being used as breeding grounds and identify what species are used. Our objectives were to document which wetlands have frog populations, document what species of frog, and determine the relative abundance by species. Our study area was the Alapaha and located it encompasses 6,800 acres, which is home to 54 wetlands. These wetlands are essential for frogs. The history of the WMA is it was used for row crop agriculture, and when the DNR acquired it, they turned it into upland pine.
So moving into our methods, we separated the methods into 3 separate sections: our selection of the sampling location, our field sampling methods, and then the actual statistical analysis. Going into the selection of our sampling locations, Dr. Lane gave us a map of the ephemeral wetlands. Unfortunately, that map was a JPEG file, so we couldn't actually pull out acreages. So the first thing we had to do was put that JPEG into ArcGIS and then digitize each wetland. This map here shows all of those ephemeral wetlands digitized and put on the map. Now that we had this map, we could then take each wetland, find the acreages, and then put them into 4 categories based on acreage. Those categories are 1 acre and less, 2 acres, 3 acres, and 4+ acres. Shown here on this map, color-coded based on the acreages. Now that we had this categorized, we then plugged those acreages into Excel and ran a random number generator on each category to find the 5 from each category that we would collect from. This is the map of the selected wetlands that we took data from. Going into our field sampling, now that we have the actual wetlands we're going to collect from, we then started visiting. Each wetland was collected from 3 times, and we separated the 20 wetlands into 2 sides. We called them the north and the south. We had 10 for each side, and the way we collected was the first time we'd go out, we would collect from the north 10. The second time we'd go out, we'd collect from the south 10. And the next time we visited the north side, we would flip and go from 10 to 1, and the next time we visited 1 to 10. This gave us variations in times to make sure that we were collecting as many species as possible. We also took a GPS unit with us, and we would drop the points at the wetland that we would then return to. This gave us a dedicated spot at each wetland to collect data from.
For our data collection process, each visit had a cooldown period of 5 minutes. During this rest period, no data was collected. And this is important because arriving at the wetlands would cause disturbance and it would cause the species to stop calling. This 5-minute rest period was to counteract that. After the 5-minute period, we began the active collection process, which During this period, any and all frog calls were recorded and documented into our NAMP sheets. NAMP is the North American Amphibian Monitoring Program. These sheets gave us a standardized protocol for collecting frog species, and it also gave us a standardized protocol in weather parameters and chorus calls, which were later used for abundance. We also recorded audio for future references. This was important because when we came back from the field studies, if we felt like we missed a frog species, we would go back and listen to it, and we discovered we ended up missing a southern forest frog that was not detectable at the site. Here we have an audio snippet of a gopher frog. This is an endangered species. It sounds like an old man snoring, and it also is accompanied with spring beavers. Did y'all notice the frog? This is a little grass frog we found at one of our wells. Our statistical analysis, we did a occupancy analysis. The detection probability is the probability of detecting a species. The overall detection is the probability of detecting a species taking into account false positives. And the naive estimated occupancy is the percent of the frog species occupying the wetland. Here we have an example of the overall detection probability, where D is overall detection, P is the detection probability, and K is the survey samples. After calculating the data, we put it into this chart with the three categories to show comparison between the species. As you can tell, the spring peepers are significantly higher than the other species that we detected, while the gopher frog and the southern forest frog both share detection and overall detection probability. However, the gopher frog has the lowest naive occupancy.
So now that we have these results, we'll go over some of the species we detected were the southern leopard frog, southern chorus frog, spring peeper, southern cricket frog, and the gopher frog. We had to omit the gopher frog from this map since it is a rare and endangered species. But with this map, the two things we really wanted to show was the abundance and the species richness. Abundance of the species actually refers to the individuals of a certain species, how many individuals are there. Species richness refers to how many species are there. The abundance we're showing in chorus calls. Because we are not specifically trained and professionals in pointing out individuals as they're calling, we then refer to our chorus count. The choral index for the NAMP data sheets gave us a 1 through 3. A 1 being there's large breaks between calls, you can easily tell individuals. A 2 being there's individuals you can still tell, but their calls are overlapping. And a 3 is all out chorus, all out chaos. As you can see for our spring peepers, their main numbers were 3s and 2s, showing they're highly abundant at each wetland we detected them at. While species like the southern cricket frog has a 1, and the southern leopard frog also has a 1, showing they're not as abundant. For species richness, we showed each bar. For each species, for example, 32 has 3 bars, therefore its species richness had 3 species. Some of these wetlands, if you notice, don't have any bars next to them. Just because we didn't detect a species at a wetland does not mean it was there, we just didn't detect it during our research. A lot of the detection, especially when we had high spring peeper count, it was hard to detect certain species because of their low tone calls. For example, the spring peepers and the gopher frog, spring peeper is a very, very high tone call, very high pitch, and they're very frequent when they call. Gopher frogs is very low pitch and they don't call as frequently. So discussion of our data, we're going to quickly go through the interpretation of the data, our discovery of a gopher frog in a wetland, and then what this means for the future of the conservation of the species. So our spring peepers were highly detectable. They had a detection probability of 0.74 and an overall detection probability of 0.98. The detection probability means that when you go to a wetland, you have a 74% chance of detecting the species at specific wetlands. The overall detection probability means that any of the wetlands we surveyed, you have a 98% chance of detecting that species. The inverse of the overall detection probability gives us a 0.02%, which means any of the wetlands you visited, if you did not detect this species, there is still a 0.02 chance it was there, you just did not detect it during your survey.
The southern cricket frogs, they were also moderately detectable with a detection probability of 0.4 and a overall detection probability of 0.78. The inverse would be 0.22. With the southern forest frog, it is also moderately detectable with a detection probability of 0.33 and a overall detection of 0.69 with an inverse of 0.31. The gopher frogs were less detectable given that they are endangered and rare, making them harder to detect. To add to the complexity of this species, they only breed during rain events, and this goes against the NAMP sheet's guidelines that says do not sample during rain because it will inhibit audio detection. The detection probability for this species is 0.33, with the overall detection probability being 0.69, with an inverse of 0.31. The discovery of this species shows an increase in habitat quality. Dr. Lane releases these species on the WMA, however, she did not release the species in the area where we discovered the species at. This shows that the species themselves found a way to the new wetlands by themselves.
Another less detectable species was the southern leopard frog, with a detection probability of 0.34, an overall detection probability of 0.71, and an inverse overall detection probability of 0.29. So now that we have all this data looking into the future, we now have a baseline for a lot of these wetlands on populations. Using this and with the needed repeat surveys year to year, we can then look at the conservation strategies and see as the trends rise and fall with the populations, are they working to the benefit of the habitat, for the ecosystems in the wetlands, and what needs to change? What kind of tinkering do we need to do in these strategies? In conclusion, the better understanding of these populations in the ephemeral wetlands will help us when it comes to the conservation of the wetlands and assessing the overall health of the ecosystems found in thereof.
We would like to thank Dr. Vanessa Lane for being our advisor with this project and giving us the map of those wetlands. We'd also like to thank Dr. Woods and David Ray for being our mentors in the class and giving feedback that helped us with the paper and this presentation. We would like to thank Jedediah McQuay and Janie Benson for helping us with data collection, and we would like to thank Dr. Jason Scott for helping us with the calculation.
Are there any questions?
Any questions?
Yeah. So detection probability takes into the probability of detecting a species by itself. With overall detection, it takes in the probability of detecting a species by, oh, that messed me up. It takes the probability of detecting a species counting in the fact of false positives. Okay. So false positives is when you detect them there even though that the species is not present at the wetland.
In case you got an auditory cue wrong.
Did you have a lot of those?
Surprisingly, no. We had a lot of true true negatives.
We did have, for example, with the recordings, we talked about how we went through and at one wetland we didn't know the southern chorus frog was there, but as we were going back through our data sheets before calculation, we actually started hearing it, and therefore we started to record, okay, well, it's actually there. We started to find audio files online, replaying them, making sure that we understood that is the southern chorus frog. We did not hear it in the field, and we heard it through the audio recordings. I do not think 5 minutes was enough. One of the problems we ran into was when we would come to a wetland during that 5-minute cool down, waiting for those species to kind of chill out with our presence, there was actually a lot of frogs still calling. But the second we started our 5-minute recording, they would stop. And at that point, we can't record during the cool down, so those frogs, we know they're there, we just can't use it. And so I think having a 10-minute timer of recording would actually, it would increase your chances of those species then kicking back up and start calling.
We didn't do anything. We just pressed the record button and sat the same way as we were doing for the rest period.
Like I said,
Yeah.
we would use the GPS unit, get to that location, and we had specific spots we would sit at, and I would pull out my phone, set it at a certain location, and we sit there and wait. When my 5-minute timer went up, silent, it just vibrates on my wrist. Then I would hit record, and usually, like probably about a minute before I started recording, they'd all stop. And so it was very, very frustrating. So the main thing was when we finally had our maps of the selected wetlands, we plugged that into a Venza, and we found our way to that wetland, and we dropped a point on the edge. So wherever the map put us at the edge of the wetland where we dropped it. And usually as you're walking through there, you can see the vegetation change and know that you are entering a wetland. So we didn't want to go too far in the wetland and end up, all the frogs behind us not wanting to talk anymore because we spooked them. So we get to the edge, drop a point, and that was where we collected. So now that we have this data, one, with the discovery of the gopher frog at that wetland, we know that their conservation efforts for the pine uplands are working because it's getting these gopher frogs weren't released here. Dr. Lane releases gopher frogs at a whole different area, and this is a new wetland. And so even telling Dr. Lane the discovery of the frog there, she was surprised. She was taken aback that it was even there. So that shows that what they're doing is working. And the populations are there. We heard the species, we found species. We field truthed and walked around after collection, and we would find different species we didn't hear. Unfortunately, we can't use that data because we are calculating auditory detections. Some of them were, some of them were not. The ones that had 3, that was a good habitat. Some of them that were just spring peepers, again, I think that relates more to just the time frame of when we collected. If we would have collected longer or had more surveys, I feel like we would have collected more species. One of the things, like I said in the NAMP, we try to stay away from the rain. So we would try to probably find another protocol instead of using NAMP. That way we could use call collections during a rain.